Hey guys, today we're going to learn to complete operations with numbers written in scientific notation. Okay, follow along on your guided notes. Feel free to pause the video and replay anything that seems unclear. Okay, to add or subtract numbers written in scientific notation with the same power of 10, we are simply going to add or subtract the factors. When the numbers have different powers of 10, we must first rewrite them so that they do have the same power of 10. Okay, I left those notes at the top of this page. We're going to work two examples. Our first example, we are adding two numbers written in scientific notation with the same power of 10. So we are simply going to add the factors. So 4.6 plus 8.72, and that equals 13.32, okay? And if you notice, 13.32 is not written in scientific notation. The whole number is not between 1 and 10, so we have to fix that. We're going to have to move our decimal one place to the left. So this number would be 1.332 times 10 to the first power, because we moved our decimal one place. And then we cannot forget our original power of 10, which was 10 to the third. Now, we have to use our product of powers property to simplify this final answer. And we know that when we multiply two powers with the same base, we can add the exponents. So the final answer would be 1.332 times 10 to the fourth power. Okay, in our second example, we have two numbers written in scientific notation. And if you notice, they do not have the same power of 10. We have 10 to the negative 2 and 10 to the negative 3. So we're going to rewrite 6.6 so that it has the power of 10 as 3.5. Okay? So we have 6.6 times 10 times 10. So we want it to be negative 2. We're simply taking this original power of 10 and we're breaking it apart. So using our product of powers property, we have to think, okay, what two numbers can we add to get, so we know, or to get negative 3, to get the original power that we started with. And we know that negative 1 plus negative 2 will get us back to our original power of negative 3. Now, we can simplify this by moving our decimal one place to the left, like the power indicates, and we get 0.66 times 10 to the negative 2. So we took this boxed in version right here, and we simplified it to 0.66, and then we brought down our power of 10. Okay? So now we have two numbers written in scientific notation with the same power of 10. We can simply subtract the factors. So 3.5 minus 0.66, and that equals 2.84. And that's a good number. It is between 1 and 10, so we can go ahead and add our common power of 10. 2.84 times 10 to the negative 2 is your final answer. Okay, we're going to try two examples, one with the same power of 10 and one with different powers of 10. So if I were you, I would pause the video right here, try the first example, and then watch me work it out, and then try the second example and watch me work it out to make sure that you have the hang of this. Okay, so here we go. 8.2 times 10 squared plus 3.41 times 10 to the negative 1. We have different powers of 10, so we must fix that. Okay, so we're going to rewrite 3.41 to have the power of 10 as the first number, 10 squared. So that's going to be times 10 times 10. And we want it to be the same as the first number. So, what two numbers can be added together to come back to our original power of 10? What plus 2 will equal negative 1? And we know that that number would be negative 3. And you can check that off to the side using your product of powers property. Two numbers, two powers with the same base, you can add their exponents. Okay, so back to our original power of 10. Now, we need to simplify this part so that we're only left with 10 squared. And this tells us that we need to move our decimal 3 places to the left. So 1, 2, 3. And our new number is 0.00341 times 10 squared. We bring that down. Okay? So both of our numbers now have the same power of 10, so we can simply add them. We get 8.20341. That's a good number. It is between 1 and 10, so we're ready to finish our answer in scientific notation. Final answer. Okay? Another way to check your work is to take both of the original numbers written in scientific notation and convert them to standard form, add them like normal, and then convert your answer back into scientific notation. You have to make sure that your answer is written in scientific notation if the instructions tell you to do so. So 8.2 times 10 squared, if we converted that to standard form, we would get 820. We would move our decimal 2 places to the right, plus 3.41 times 10 to the negative 1 power, we would get 0.341, because we would move our decimal 1 place to the left. If you add these two up, that is most definitely not in scientific notation. We should move our decimal 2 places to the left, and your new number would be 8.20341 times 10 to the second power, because we moved our decimal 2 places. And this way matches our original way. So just a way, an alternate way to do it, or a way to check your work. In example number 2, we are subtracting, and we see that both of our powers of 10 are the same. So that makes it easy. All we have to do is subtract the factors. And because our answer must be in scientific notation, we need to check the factor, and it's good. It is between 1 and 10, so we're going to go ahead and write our common power of 10. Final answer is 3.3 times 10 to the negative 5th power. Okay, now moving on to multiplying and dividing. To multiply or divide numbers written in scientific notation, we are going to multiply or divide the factors and the powers of 10 separately. Okay, so we're going to have to recall our exponent properties. All right, in our first example, we have 3 times 10 to the negative 5th times 5 times 10 to the negative 2. We want to make sure that we write our answer in scientific notation. So, we are going to multiply 3 times 5, and then we're also going to multiply our powers of 10, 10 to the negative 5th times 10 to the negative 2, okay? 3 times 5 is 15, and 10 to the negative 5th times 10 to the negative 2, when you multiply two powers with the same base, we know that we can add our exponent, so that would be 10 to the negative 7. Now, we have to check and make sure is our answer in scientific notation. And in this case, the answer is no. 15 is larger than 10, and our factor must be greater than or equal to 1 and less than 10. So we're going to have to move our decimal one place. So that becomes 1.5 times 10 to the first power times our original power of 10, 10 to the negative 7. Now we have to simplify using the product of powers property. So we have 1.5 times 10 to the negative 6 power. That would be your final answer. There you go. I wanted to show you the book version. Now we have a division example. 1.5 times 10 to the negative 8 divided by 6 times 10 to the 7th power. Now remember, when we were studying our exponent properties, we talked about how you could break this apart. So that's what we're going to do. We're going to rewrite this as the product of two fractions. Okay, so we have 1.5 divided by 6 times 10 to the negative 8 divided by 10 to the 7th power. So off to the side, you're going to have to do some scratch work. No calculators allowed. So top in, bottom out. And 6 will go into 15 twice. 6 goes in, so we get 0.25. 0.25 times 10. Now, when we divide two powers with the same base, we can subtract their exponents. So we have negative 8 minus 7, which gives us negative 15, okay? We want to check and make sure, is this answer in scientific notation? The answer is no, because 0.25 is less than 1. So we need to move our decimal one place. We get 2.5 times 10 to the negative 1 power. And then we got to bring down our original power of 10, okay? Now we go back to our product of powers property. We want to combine these two guys. So 2.5 times 10 to the negative 16th. This would be your final answer. Okay, so now we have 4 examples for you to try on your own. So what I would do is I would try the first example. I'd pause the video, try the first example, and then play to see me work it out and make sure you got the correct answer. And do that for each example. You try it first and then watch me. So in the first example, we have 6 times 8 times 10 to the 5th. So we're going to multiply the two factors. 6 times 8 equals 48. And there's no other power of 10 to multiply by, so we're just going to bring that down. We're going to check to make sure this is scientific notation. The answer is no, so we have to bring that over. We moved our decimal one time, and then we have our original. We need to simplify this using our product of powers property. Final answer, 4.8 times 10 to the negative 4th power. Number 4, we're going to multiply the two factors. 7 times 3 equals 21, and 10 squared times 10 to the 5th equals 10 to the 7th. So we have 21 times 10 to the 7th. 21 is not in scientific notation. We're going to move our decimal one place. Bring down our original power of 10. We have to simplify that. 2.1 times 10 to the 8th power. Number 5, 9.2 times 10 to the 12th divided by 4.6. So we are going to divide our factors, and then we have only one power of 10, so we're not going to have to do anything with that. So off to the side, 9.2 divided by 4.6, and we have 46. That goes in 2 times. So we have 2 times 10 to the 12th. 2 times 10 to the 12th. And that is in scientific notation. So you are done. In example number 6, same thing. We have 1.5 times 10 to the negative third divided by 7.5 times 10 squared. So off to the side, we have to do our division. 75 will not go into 15, so we got to add a decimal 2 times. Okay, so we have 0.2 times 10, we got negative 3 minus 2, negative 5th power. 0.2 times 10 to the negative 5th power. 0.2 is not scientific notation. We're going to have to fix that. So we move it 1 time to the right. Bring down our original. This needs to be simplified. So our final answer is 2 times 10 to the negative 6th power. We're going to add those exponents. Okay, so this is the end of our lesson. Like I said, feel free to go back to any part that you need help on, pause at any point, play it again. And from this point, you are going to work on your practice sheet that you already have, 16.7, and we'll post the answers on the board for you to check your work with. And I'll see you guys tomorrow. Have a good day.